Combinations of functions. So first we're going to look at the domain of a function. And for each one, we start off with the set of real numbers, and then we look for exclusions. We have two things to watch out for. Denominators. A denominator can never be 0. And square roots, because your radicand has to be greater than or equal to 0. Because you're starting with real numbers and then excluding, so you're not going to be able to have any complex numbers. So for each of these, we're just going to look at their domain. That's all this is asking. For the first one, we have all real numbers. There is no denominator. There's no radical. So it is still all real numbers for the domain. So we can write that as negative infinity to positive infinity. The next one, we have a denominator. So we have to see what our exclusions are. We need to know, when is this denominator 0? So it is a quadratic. We're going to factor and set each one equal to 0. So we should be able to use 3 and 1, and I think the 3 will go here. So x equal to negative 1 is bad, and x equal 3 is bad. So we're going to throw those away. So we have the set of real numbers, and we're going to exclude those. So a couple of ways you can write it. You can write it with set builder notation. The set of all x such that x is an element of the reals. And then you can write your exclusions. It's not equal to negative 1, and it's not equal to 3. That's one way to write it. Another way to write it would be with interval notation. That would be going from negative infinity to negative 1. Right. We're going to use parentheses because we don't want to include negative 1. Then you start again from negative 1 to 3, but also with parentheses, so you're not including either one. And then you start up again at 3 to infinity. That is leaving the one piece out. Our last one that's here, it has a radical. So we have to make sure that 3x plus 12 is greater than or equal to 0. So we're going to subtract 12 from both sides. I'm going to move back this way just a little bit. And divide by 3. It's a positive 3, so nothing's going to flip. So x is going to be greater than or equal to negative 4. So your domain on this one is from negative 4 to infinity. For this first problem we have here, we just have to check the denominators. So x cannot be negative 5, and x cannot be 3. So we're going to throw those out. You can either do set builder notation, x such that x is an element of the reals, and x is not equal to, we could do these both in the same condition, negative 5 and 3. Or you can use interval notation. We're going from negative infinity to negative 5. Use parentheses. Start up again at negative 5 to 3, parentheses, and then start from 3 to infinity. For our next one, we have a radical and it's in the denominator. So the first thing is under the radical, this would have to be greater than or equal to 0, but square root of 0 would be 0, so we don't want that one. So we're going to have to just do x minus 2 greater than 0. All right, we're taking care of the two things there. The denominator can't be 0, so that's why we don't do an equals underneath here. So add your 2 to both sides. X has to be greater than 2. And so you are going from 2 to infinity. We have one more problem to look at. So we're starting with the set of real numbers. First of all, for our denominator, we're going to have to throw away 5 because 5 minus 5 would give us 0. So we're going to say x cannot be 5. That's from the denominator. For the radical, our radicand has to be greater than or equal to 0. Here it's okay if it ends up being equal to 0 because it's on the numerator. So we're going to add 2 to both sides. And here we have our conditions. So we can use set builder notation. X such that x is an element of the reals. X is not equal to 5. And x is greater than or equal to 2. Right? And the other way is with interval notation. We're starting at 2. And we're going to go from 2 to 5. Now, we don't want to include 5, so we have to use a parentheses there. Union. Start at 5 again to infinity. So now we're going to look at the arithmetic of functions, add, subtract, multiply, and divide. And we have to state the domain of each one, and then the domain of the result will be what is common to both, the domain of f and the domain of g. So first thing we're going to do is add them together. You have two different forms of notation. You could do f plus g of x, or you can write them separate, but it just means add the functions together. So we have 2x minus 1 plus x squared plus x minus 2. And it's just going to be a matter of combining like terms. So we'll go with descending order. We have x squared. We have 2x plus x is 3x. And minus 3. So that will be our answer. The domain of the first one is all reals. The domain of the second one is all reals. You have no place for restriction. So the domain here will be all reals. Next, we're going to subtract the functions. You just have to make sure that you watch out and distribute your minus to all of your second one. So our f of x is going to be 2x minus 1. And again, you have two kinds of notation. You could do f minus g of x or separate f of x minus g of x. All right, and then we're going to subtract all of this one, x squared plus x minus 2. Make sure you distribute. So minus x squared minus x plus 2. And now you're going to combine like terms. So we have minus x squared. We have 2x minus x will be plus 1x. And we're going to have plus 1. For your domain, the domain of the f of x is all reals. Domain of g of x is all reals. So the domain of the result is what is common to both the domain of f and the domain of g. And so it's all reals. Next, we're multiplying the two functions. And again, your two kinds of notation, you could do fg of x or f of x times g of x. Right, and this is going to be a binomial times a trinomial. So I'm going to put the shorter one in the front, which is our f of x. And I'm going to distribute twice on this one. So I have 2x times x squared will be 2x cubed. I have 2x times x is 2x squared. 2x times negative 2 is negative 4x. Right, then I'm going to switch and distribute the negative 1. So minus x squared minus x plus 2. And then combine like terms. So there is no other x cubed term. X squared, 2x squared minus 1x squared is x squared. Minus 4x and minus 1x is minus 5x. And plus 2. Then for our domain, the domain of f is all reals, domain of g is all reals, so the domain of multiplying them together is all reals. So next we'll do our division of the functions, and we do have a note to exclude from the domain values of x that cause the denominator to be equal to 0. So we'll just write it vertically. And we could try to factor. If we factor this one, we would use 2 and 1 with different signs. So a 2 here, a 1 here. And that would work. Nothing cancels with our numerator. So our answer would actually still be the same thing. And you can write factored form, or you can just leave it either way. We do need the factored form, though, to see what to throw away from the domain. So a negative 2 or a 1. So in our domain, x cannot be negative 2 and 1. So you can use your interval notation or set builder. I'm just going to do set builder. X such that x is an element of the reals, and x is not equal to negative 2 and 1. All right, we're going to do the same kind of thing. We have two new functions here, and first we're going to add them together. So we are adding square root of x plus x minus 3, and that is going to be the final answer. For your domain, you do have a restriction on this one because it has a radical. X has to be greater than or equal to 0. No restriction on this one. But you have to do what's common to both. So for this one, the domain will be x is greater than or equal to 0. So I will use interval notation. So 0 to infinity. All right, when we're going to subtract them, we just have to be careful and distribute that minus to the second one. So our f of x is square root of x minus x minus 3. And it's fine to just go ahead and do that. I'm taking this step just so that you can see I'm making sure to do that. It will have the same domain because it's the same for each of them. Right, and multiply them. So I have square root of x times x minus 3. So I will have to distribute. This will stay outside the radical. So I have x times square root of x, and I have minus 3 times square root of x. And there's nothing else you can do there. If you tried to put it together more, it would just get you back here. And its domain is also the same, 0 to infinity. So for our division, we'll just have square root of x over x minus 3. For our domain, we have just one extra thing to do. The thing that's common is x has to be greater than or equal to 0, but we can't let a denominator be 0. So x cannot equal 3. So we have two things going on. These are our restrictions. So let's do interval notation. So we're going to start at 0. We're going to go up to 3, but we don't want 3. So we have to use parentheses. And then we will start again at 3 to infinity. And that is how you leave the 3 out. Right, for our last problems that we're going to do the arithmetic on, we do have restrictions in the domains of f and g. So we're not going to be allowed to have a denominator equal to 0. You can factor and so you're going to have to throw away negative 5 and 5. And that is true for the domain of both. All right, so first we're going to add them together. So we're going back to old addition of fraction rules. And if you remember, when you add fractions, you have to worry about a common denominator. Fortunately, we have a common denominator, so our rule says keep it. Combine the numerators, and this is addition, so we can just combine like terms. 2x plus x is 3x, and 3 minus 2 would be plus 1. You would need to see if it will simplify. This is x plus 5x minus 5. Nothing divides out with that numerator, so we can leave it in this form. Your domain of this final answer has these two restrictions. So your domain is from negative infinity to negative 5, union negative 5 to 5, union 5 to infinity. So that you're throwing away the 5 and the negative 5. Next, we're subtracting these functions. Very similar to addition. Back to the rules of fractions. Make sure that you have a common denominator, but we do. So you're going to keep the common denominator, combine numerators, just take time to distribute, so that'll be minus x and plus 2. So I have 2x minus x will be x, and 3 plus 2 would be plus 5. This will reduce, and so our denominator here is x plus 5, x minus 5. And so you can divide out the x plus 5. Your answer is 1 over x minus 5. For your domain, it's still the same as we had before. You have to throw away negative 5 and positive 5 so that you have what is common to both. So domain is going to be, I'm just going to write our restrictions and not write it formally again. So negative 5 and 5 are thrown out. Next, we will multiply these rational expressions. So we have 2x plus 3 over x squared minus 25 times x minus 2 over x squared minus 25. And for rational expressions, you factor everything and divide out. We know what these are made of. They're x plus 5, x minus 5. They're not going to cancel with anything on the diagonals. So I'm not really going to multiply this out. It is standard practice to leave it in a factored form. I can factor the denominators if I want. I have x plus 5, x minus 5, and I have that again. And there's nothing you can do. Nothing divides out. So I would leave it right there. Your domain is just going to throw away negative 5 and positive 5. Next we have a division. And so we have 2x plus 3 over x squared minus 25 divided by x minus 2 over x squared minus 25. And you can write it across as division, or you can work on it as a complex fraction. If you work on it as a complex fraction, you find the common denominator of both fractions, and it would be x squared minus 25. And so we would multiply by that up here and down here, because that is really 1, and that will cancel both denominators and gives us 2x plus 3 over x minus 2. So what we have to watch out for here for our domain, we have thrown away negative 5 and 5. We also have to throw away 2. So x cannot be negative 5, 2, or 5. I wrote the other form of division out for you just if you were bothered by the complex fraction. You would write it as divide. Remember, to divide fractions, you multiply by the reciprocal. So you change it to multiplication and invert the divisor, which is what I did. And then you can cancel on your diagonals, and we're left with 2x plus 3 over x minus 2. Same answer, same domain.